And hello again, Year 9. Welcome to part 3 of Lesson 2, where we have our last look for today at atomic structure. So now we're going to have a look at this neutron number. It's a strange thing because I've said that the neutron number can vary. Now, what do we do then if we're asked to draw an atom? How do we figure out how many neutrons that we draw? Now, over here I've got a picture of a lithium atom drawn in the style I showed you in my last part. And lithium is an atom I actually drew back in part 1 as well. So let's have a look at lithium. It has 3 protons because its atomic number is 3, as indicated by the periodic table. I hope we remember that. But it also has 4 neutrons if I'm supposed to draw it. Why do I pick 4? If I know that there's other lithiums out there with maybe 3 neutrons, maybe 5 neutrons, why do I do the one with 4? Well, we sort of assume that 4 neutrons is the number of neutrons that most lithium atoms have. But how do we come to this assumption? Well, we've got an equation for it. So let's have a look. So over here we have a tile or a symbol that you would expect to find for every chemical element. And here it is for lithium. We have our atomic number of 3, we have our symbol of Li, we have our atomic mass of 6.941. Now remember, I said that the atomic mass is an average of all the masses of lithium atoms. It's kind of close to 7, so I think we can assume that most lithium atoms have a mass of 7. But there's always going to be a minority with a little bit more mass and a little bit less mass. Now, as we said in the last part, this difference in mass comes from only one source, and that is neutron number. Now, lithium never changes in proton number, or it's no longer lithium. So we can't change the proton number to get things to be heavier or lighter and keep it as lithium. We can only change the neutron number, and that's what happens. So when we ask you to draw a picture of lithium or to say what the neutron number of lithium is, we want to know what that most common neutron number is. So to do that, we have to round off this number to the nearest whole number. Now, as we can see, it's 6.9, which is closer to 7. So we round it off to 7 for our calculation, which is here. So neutron number is equal to the atomic mass of an element, rounded off, minus that element's atomic number. So I've done that for lithium here. Neutron number for lithium is 7, which is the atomic mass rounded off, minus the atomic number, which is 3, giving us a neutron number of 4. So in a test, if you're asked, what is the neutron number of lithium, you'd write 4, using that calculation. Or if you're asked to draw a lithium atom, you'd have to make sure that you put 4 neutrons in the nucleus, because that is the most common neutron number for lithium. Now, when we do this calculation, like I said before, we are often finding the most common isotopes neutron number. So why wouldn't we draw the most common one? If we're going to look at a lithium atom and the chances are it's going to be one with 4 neutrons, well, we should probably draw the most common one. But don't forget, there's always going to be those other isotopes, those other lithium atoms that differ in neutron number. Now, I've applied this calculation to 3 other elements down here, okay? Now, helium, when you look on the periodic table, you'll see that its atomic mass on its square is 4.003. So in that case, I need to round that 4.003 off the 4. Very easy to do, isn't it? And I simply subtract the atomic number for helium, which when you look on the periodic table is 2, and I end up with 2. So if I draw a helium atom, or if I'm asked what the neutron number of helium is, I'd just say 2. Very, very straightforward there. And you probably remember from the last part, or the first part of lesson 2, I actually drew a helium atom, and I very much purposely drew it with 2 neutrons because of this calculation. Most helium atoms have 2 neutrons. But, of course, there are others. There are other isotopes out there. Helium-3 certainly exists. Maybe there's helium-5. But what we can be safe in the knowledge of is that there's plenty of helium-2. It is the most common isotope. The second one I've done over here is boron. Boron is number 5 on the periodic table. So therefore it has 5 protons. Now its mass on the periodic table, when you have a look at its square, is 10.81. Now this one has to be rounded up this time, just like the lithium. So we just say it's 11. 11 minus 5 equals 6. Therefore, the neutron number for boron is 6. Now, last example, carbon. We've looked at this a few times. I said that the most common isotope of carbon is carbon-12 with 6 neutrons in its nucleus. Well, this is how we prove that. I find the atomic number of carbon, which is 12.01, and round it off to 12. Sorry, my mistake. I find the atomic mass of carbon, which is 12.01, and I round it off to 12. And then I subtract the atomic number of 6 to find out that the neutron number of carbon for most isotopes is 6. And what have we noticed? The most common neutron number for boron and carbon is 6. So I think there's a school bell. Wasn't expecting that. This further clarifies that it is the proton, the atomic number, that's important in distinguishing what the element is. If I said to you which element has a neutron number of 6, well, there's more than one answer, isn't there? Might be a bit confusing. So we use the atomic number to distinguish between our elements, not their mass, because the mass is always so variable that it'd be very, very confusing. We stick to what's concrete, and that's neutron number. Pardon me, another mistake. We stick to what's concrete, and that's atomic number, proton number, never changes. Otherwise, it's a different element in total. Remember, if I take one proton away from here, I'm going back to 2. I've got helium. So we never change the proton number. It is only the neutron number that can change. And if we're asked for the neutron number, well, we just find out what the average and most common one is by rounding off the atomic mass and subtracting the atomic number.